let's hop aboard a rocket ship and zoom into space where we can get up close to the planets.
Welcome to Dubai. Dubai is a city of skyscrapers, ports, and beaches where big businesses take place alongside sun-seeking tourism. Because of its large expatriate population, it feels like a Middle Eastern melting pot. Today our trip will be to Expo 2020. Expo 2020 brings the entire world to Dubai to meet the 192 participating countries in their own standalone pavilion. Expo 2020 Dubai theme, Connecting Minds, Creating the Future, will be a celebration of human achievement and innovation, inspiring the future generation to spark active ideas. Besides showcasing the cutting-edge and futuristic vision of Dubai, the Expo will also enhance the UAE's international reputation in terms of rich cultural heritage, business growth, and tourism.
I am looking forward to join this event. I really want to know much more about the James Webb Telescope.
I am as much excited as you are.
Come for the greatest global gathering in history, with countries from all over the world. Discover the world's most inventive ideas. See devices that extract water from air, concrete that generates solar power, and the most sensitive radio telescope ever made. Marvel at the world's most inspiring architecture. Step into structures that produce electricity, spaces that change shape, and buildings that send messages to space. Experience the world's greatest entertainment with local and international stars, live concerts, and colorful parades. Take in inspirational art, sample exotic cuisines, and witness more than 190 countries and cultures come together in one place.
Expo, a large international exhibition. Let me introduce myself. I am here to guide you through this experience. Today we are having a new and special event, the Space Vision Pavilion, and it is located in the NASA Pavilion.
I can't wait to go through this experience.
I'm just as excited as you are. Let's start this journey.
Let's have a quick walk to any two pavilions of your choice.
I would like to visit the United Arab Emirates Pavilion.
I've heard a lot about the Switzerland Pavilion. I would be more than glad if we can have a walk around it.
I will leave you here. I hope you had fun at the pavilions. And you will meet my friend Khalid. He will lead you to the NASA Pavilion. Make the most of your journey.
Hello, this is Khalid, who will be leading you to the next part of the trip. Let's start this event.
Precisely because of the obscurity of our world, thus we view
and gentlemen. I am Mariam Al-Samahi and I will be hosting today's event. I'm so pleasant to welcome you all to one of the most important launches that NASA have ever made, the James Webb Telescope. Let's not waste some more time and start the event. I would like to welcome Abdullah Al-Blushi, Abdulaziz Al-Mansouri, and Maria Al-Hammadi. They are some of the scientists that helped in inventing the James Webb Telescope. The stage is yours.
Good evening, everyone. I'm Abdullah, and here is my friend. Today, we are here to introduce you to the James Webb Telescope. The James Webb Space Telescope is the world's largest, most powerful, and the most complex space science telescope ever built. Webb will solve mysteries in our solar system, look beyond to distant worlds around other stars, and probe the mysterious structures and origins of universe and our place in it. Webb is an international program led by NASA with its partners, the European Space Agency and the Canadian Space Agency.
James Webb Space Telescope is the world's largest, most powerful, and most complex space science telescope ever built. Webb will solve mysteries in our solar system, look beyond to distant worlds around other stars, and probe the mysterious structures and origins of our universe and our place in it. Webb is an international program led by NASA with its partners ESA, European Space Agency, and the Canadian Space Agency.
The James Webb Telescope is the next chapter in space-based telescope astronomy. The Webb mission builds on the legacy of the Hubble Space Telescope's powerful imaging capability and Space Telescope's ability to detect light beyond the visible spectrum into the mid-infrared range, because infrared light travels toward dense gas clouds that block visible light. Webb will reveal previously hidden regions of the universe, early galaxies, forming planets, brown dwarfs, and much more.
We've got this image. It's basically describe the Webb journey to its orbiting position beyond the moon, approximately 1 million miles from the Earth.
Our colleague Maria would like to share with us some more information about the Webb Telescope.
Each science instrument has innovative features that allow astronomers to study a range of astronomical objects in multiple ways. The James Webb Space Telescopes for scientific instruments are capable of examining the universe across a range of light called infrared, which is beyond the red end of the visible light rainbow. Webb also captured a little visible red as well. Infrared wavelengths are broken down into near-mid and far infrared range. Each instrument has unique features that allow astronomers to study a variety of astronomical objects in different ways. As Webb primary camera, an IR cam, look at near-infrared wavelength, known as near-infrared because these wavelengths are near to the red end of the visible spectrum. It can detect light from the earliest galaxy in the process of information, star in nearby galaxy, young star in Milky Way, and object from a distant region of our solar system called the Kuiper Belt. The instrument is also important to exoplanet research. It is coronagraph and time series imaging capability allows it to track the motion of exoplanets as they orbit their star. Near-infrared spectrograph, an IR spec. An IR spec is a multiple object near-infrared spectrograph. A spectrograph is a device that breaks light up into its component, color for detailed analysis. An IR spec detects near-infrared wavelength, and it's capable of observing more than 100 objects simultaneously thanks to its innovative micro-shutter assembly. It is designed to study, among other things, star formatting and the chemical composition of young distant galaxies. IRI has a sensitive camera and a spectrograph to study a distant stellar population, the physics of newly forming star, and the size of faintly visible comet and Kuiper belt object. MIRI is also equipped with a coronagraph, which blocks the glare of a bright object to allow clear observation of faint objects close to it, like exoplanet orbiting a star. Fine guidance sensor, near-infrared imager, and slitless spectrograph, FGS NIRISS. FGS is a waveguide camera which help point the telescope. NIRISS gathered spectra like NIR spec and capture image of the universe at near-infrared wavelength like NIR cam, observing both extremely bright and faint objects. NIRISS will be particularly useful for studying the composition of exoplanet atmosphere, among other research. FGS and NIRISS have different purposes but are packaged in one unit.